Suppose you're given that 15 students do drama, they're in the drama club, 13 are on the newspaper staff, okay, and 4 do both. Okay, so this is a total of 15 people in drama, a total of 13 people on the newspaper staff, and from that whole mix, 4 of them are on both. So the question is, HM, how many do only drama? And I could also ask how many do only newspaper. It's going to be the same thing. It'll probably come out in the wash here. Okay, so let's make a Venn diagram, because I just asked you that question off the cuff without knowing Venn diagrams. You'd have a fun time playing with it. Maybe you'll get the answer, maybe you won't. So knowing how to work with Venn diagrams, you'll always get the answer. Okay, so let's look at what we have here. So we have a total of the drama and the newspaper. Okay, a total of 15 in drama and a total of 13 in the newspaper. Okay, but how to start? Where do you go? Well, the way you start is look at the overlap. This is the most specific piece of information we have. We know that 4 do both. Okay, well, let's look at it now. If 13 are in the newspaper all together and 4 are also doing something else, how many are only in the newspaper? Okay, 13 in the newspaper, 9 minus 4 of which of the 13 are also doing the other thing, the drama. Okay, that leaves 9. So that means you have 9 here who are only, okay, only newspaper. 4 here, together they make 13. Okay, what about here? We know of the drama people, 4 also work for the newspaper. So that leaves 11 in the section here who only do drama. Well, that was the question, right? How many only do drama? There's your answer. Okay, 11. Okay, that's a very methodical method. You know, that's repetitive. It's a very clear method for attacking these problems, and they can be with multiple clubs. It doesn't have to be 2 or 3. It could be more. But let's do another one. Now let's look at a more complex problem. Okay, I really think anybody would be hard pressed to solve this problem without Venn diagrams. So here's a school situation. We're looking at 3 clubs, okay? 23 people in the debate club, 27 people in the chess club, 32 people in the environmental club, and then further we give you information that there are 7 people in the debate and the environmental club together, and 6 in the environmental and chess, 5 in the chess and debate, and 2 of them are in all 3. Okay, that's easy enough to say. And what is the question? The question is, how many students are involved in these 3 clubs? Let's make believe they're the only clubs in the school. Okay, how many people are involved in the 3 clubs? I'm double counting people. You just can't add them up. First of all, it's not written in a column as if they would be added up, because you're not going to do that. So you're not going to add them up. You're going to have to figure out how many students are involved, because 2 of them are in all 3 of them. I mean, that gets complicated. The only way that I know of how to solve this problem, and these are set problems, these are really set problems, is to use the Venn diagram method. So I'm not going to erase this information because we're going to be referring back to it, but I made a separate Venn diagram, okay? And we'll refer back to both, okay? So to start, you're always going to start with the most complex case. Start from the middle and work out. If they ask you a different kind of question, then you may not be given the middle point. They may give you everything else, how many people are in each of these, they may tell you how many total, and you'll have to find that one. But if they give you the middle one, that's the place to start. Okay, so the middle one represents the group of students who are in all three. Well, who's in all three? Well, there are 2 people in all 3 clubs. So I put a 2 here. Hope you can see that. The 2 represents people who are in all 3 of the clubs. Okay? Now, we work out from there. Well, how many people are in chess and environmental? Both, these 2, but not all 3. Chess and environmental, let's put it this way, chess and environmental. Chess and environmental, okay, is 6. Well, there are a total of 6 people in this overlap area. Okay, so if there are a total of 6, and 4 of the 6 are doing all 3, 2 of the 6 are doing all 3, that leaves 4 who are doing just chess and environmental, and they would be here. Okay, so 2 of them are doing all 3. 2 of those people are in my chess and environmental overlap. Okay, so the 6 that says chess and environmental, that's adding up to 6. What about environment and debate? You know what, I had changed the problem because we used newspapers before. This should be environmental. Okay, got rid of newspapers just to make it an interesting problem. Okay, so debate and environmental would be 7 total. Okay, there are 7 people who are in debate and environmental. That's this football shape overlap. Of the 7, 2 are in all 3, so that leaves 5. Okay, 5 that are in only debate and environmental, and 2 are in all 3. So there's your 7, debate and environmental. What about the overlap between chess and debate? Chess and debate. Okay, chess and debate. There are 5. Well, 2 of them are accounted for. The 2 are accounted for. The 3 that are not accounted for would be here. Okay, the 3 that are not accounted for here. So these 5 represent debate and chess. These 7 represent debate and environmental. These 6 represent chess and environmental. Well, now we're getting somewhere. We're getting somewhere because we know that 23 people are in the debate club. Well, what do I have here? I have 10, don't I? I know where 10 of them are. 10 of them are already in the debate group, right? Well, how many are in here but not here? Okay, how many are in here? So this would be the 23 minus the 10 that I already accounted for. Okay, so this group here is going to be 13. That's the group that's in the debate club, but no other club. Well, what about the chess club? Well, the chess club has 27 people altogether. We can account for 9 of the, 9, 5 and 4. We can account for 9 of them. So what does that leave for those who do chess and only chess? How about 18? Double check, 18 plus 9 is 27. All right, so this group here, 18, okay, do chess and environmental, these do chess and only chess. They do not do debate or environmental. And the last thing here, okay, is how many people do environmental only. Okay, well, of all the environmental people, there are 32 of them. 32. Okay, 32 people here altogether. So 32 is the total number, but we can account for 11. 6 and 5 is 11. So how many is left? Okay, so that would be 21. So 21 okay, is the number that does only environmental and not the other. Well, this is a complete breakdown. A lot of different questions could be asked of this, okay? And the question that we started out with, how many students are involved in some of the, in the clubs altogether? Okay, how many students are involved in clubs? So we would have to add all these different areas together. All right, so let's do that. 13, it's a little bit hard to read this. Can you see this? 13 and 3 and 2 and 5. And also 13, 3, 2, and 5. And also 18 and 4. Okay, and also the 21. Okay, how many different areas are there? There are 1, 2, 3, 4, 5, 6, 7 different areas. 1, 2, 3, 4, 5, 6, 7 numbers. Okay, so you add them up, and that's how many people are involved in clubs. And what do we get? 3 and 3 is 6, and 2 is 8, and 5 is 13. 13 and 8 is 21, and 4 is 25, and 1 is 26. Carry 2, 3, 4, 6. So there are 66 students involved altogether. Okay? All right. So that's just one example. These problems, I made this one up. They can be found online. If you want to just practice some more, you could just Google Venn diagram problems, and there are tons of them. And we'll do more as time goes on. Okay, let's stop at this point.